Two computer programs developed from the Science and Technology series are available on disc for the BBC B Computer, together with a booklet for teachers. These can be obtained from GSN Educational Software, 214 Stamford Street, Ashton-under-Lyme, Lancashire, or from the Education Officer of your local ITV company.
The following day, the Duchess goes on to Birmingham to open the new airport that has cost well over £250,000. The rain is pouring down, and at the last moment the ceremony has to be moved from the open platform to the shelter of a balcony. And this sudden change of plan results in the Duchess being partly hidden by the microphones.
I now have much pleasure in declaring the airport of Birmingham open, and in wishing it, and on all those associated with it, every success.
In the early 1970s, it became obvious that Elmdon Airport was too small. A larger airport was needed to allow West Midlands business people to fly directly to more European countries. There was a demand for more holiday flights.
But more aircraft can mean problems for those who live near the runways. Not all that extra noise will be from aircraft landing or taking off. Even passengers generate noise, and so do their vehicles. Each aircraft will need supplies for the flight, and that can be a noisy business. Aircraft move around the airport, preparing for takeoff or returning after landing on the runway, and that can be very noisy.
Tim, tell me all about this equipment and what you do with it.
This is a sound level meter. There's a microphone on the top which records the sound of the aircraft as it's taxiing along the runway, which passes into amplifiers and the meter. The sound is then passed onto the tape recorder for future analysis in the laboratory.
Right, and what sort of measurements do you get?
The basic measurement on the meter is a dBA measurement. The sound level is peaking at about 90 dBA.
A quiet countryside may produce a reading of 25 to 30 decibels, 25 to 30 dB. The sound level in this shop is around 55 dB. And the background noise in this factory registers 85 dB. At takeoff, a large jet can produce up to 140 decibels. At Birmingham Airport, taxiing aircraft produced a peak reading of 90 dB. And although that's noisy, no one actually lives on the airport itself. But people do live and work quite close by.
Now, Tim, what sort of reading did you get there?
That was peaking at about 90 dBA.
Which is about what we had on the apron of the airport itself, wasn't it?
That's right.
Airport planners need to consider the noise made by aircraft in the air and on the ground.
Right, Tim, well, here we are at the bottom of the mound with houses over there and people living in them. And on the other side, the airport. What sort of readings are you getting on your meter now?
Well, the level's around 45 dBA, which is the level I'd expect from this sort of area.
Right. Well, shall we walk up and see how it progresses?
Yes.
It's quite a height, is this thing, isn't it?
Yes, I would imagine it's around 20 metres, 25 metres.
What sort of readings now?
Well, as you moving up the mound, so the levels start to increase.
Right. Well, let's see what we get when we get to the top.
We're getting up to about 90 dBA. That's the level we were getting down on the apron. And basically, the mound is having no effect because we've now got a direct line of sight down to the aircraft.
Taxiing aircraft produce noise. That noise is carried to buildings around the airport. Close to, the noise level can be very high. Earth mounds place a barrier between buildings and aircraft. Now the noise has to travel over the top of the mound to be heard on the other side. The noise has to travel further. In the houses, it sounds less noisy. Once the aircraft has left the ground, earth mounds can do nothing to cut down the level of noise that reaches surrounding buildings. Many airports monitor takeoff noise with meters near the runway. Those meters help produce noise maps. The most noise is heard at takeoff, and the noisiest areas are along the line of the runway. Airport planners try to make the inner, noisy areas as small as possible. But that needs the cooperation of the pilot.
Well, we have three basic techniques to reduce the noise that the aircraft makes. The first one is the actual route that we use after takeoff. And here you can see this represents Birmingham's northeasterly runway. There's the city of Birmingham off to the west here.
I see.
And when we're departing to the south, we take off to the north here and turn right to avoid the city centre.
Away from the city.
The first thing is to avoid the built-up areas and not overfly them.
Right.
The second technique is to make less noise by using a reduced engine power for takeoff. We don't actually use full power on both engines when we're departing.
This particular aircraft has already been equipped with hush kits. They're fitted in the back of each engine to cut down the noise it produces.
Speedbird 968, good morning, approaching again.
968, good morning, line up 33.
Once off the ground, a British Airways plane will climb away steeply. For the pilot, an ideal flight path away from any airport is a gentle climb using full engine power. And the noise level on the ground remains high for some time. But it is possible to be less noisy. Soon after leaving the ground, the pilot reduces engine power and climbs steeply. At reduced power, the engine makes less noise, and the aircraft gets higher and further away from the ground more quickly.
When you build or rebuild an airport, then there's always at least one building that's really close to the noise of aircraft, and that's the terminal itself.
This terminal was designed to keep noise out. Windows are double glazed. double glazing reduced the outside noise from a peak of around 60 dB to 40 dB, a 20 decibel drop.
This building was designed to keep aircraft noises out, but some noises, some sounds, you need to hear very clearly indeed.
Air departure to Palma. Flight DA2838 to Palma. Passengers only are requested to
It's no good if passengers can't hear what's being said, and that's a problem for sound engineers and building designers to work out together.
This is a special room for sound measurement. It's an anechoic chamber. The walls, the ceiling and the floor are lined with these huge slabs of foam. No sound at all is reflected by the foam. And that means you can hear me perfectly well, even with the microphone a long way away. You see, there's no sound echo. The sound of my voice hasn't bounced off the walls around the room to make the speech indistinct. This room was made for bouncing sound. The walls are hard. Now you can hear me directly, but you can also hear all the echoes bouncing around from the walls. What I say is indistinct until I get near the microphone. I said you couldn't hear me clearly back there because of the sound bouncing round off the walls to produce echoes. Real buildings are somewhere between an anechoic and an echo chamber. In fact, the walls in here are rather hard. They reflect sound. And that's why the public address system at Birmingham has lots of speakers, all talking fairly quietly.
Birmingham Executive Airways departure to Stuttgart. Flight CB922 to Stuttgart. Passengers only are requested to proceed to Lounge D and have their boarding cards available for inspection.
There's one further way of cutting down noise from airports, and that's by making the aircraft engines themselves less noisy. This massive engine is one of the latest generation from Rolls-Royce. It's very much quieter than the old-fashioned jets. It's bigger and more powerful too.
Jet engines produce most noise at the nozzle. Here, the hot gases from the engine mix with the cold air around. That mixing of hot and cold gases produces noise. New engines take in a greater volume of air. Some air is passed into the engine itself. Some air is passed around the engine. The jet is less hot, and the hot jet mixes more smoothly with the air around it. The engine is less noisy.
This facility is used for testing the new range of Rolls-Royce aircraft engines.
The tests use batteries of microphones that will detect sound around the engine and then feed this data to recording equipment.
N3, 5502. 3, 2, 1, go. HP in 3. 25% fuel ignition on in 20 seconds. Lit.
there will always be noise from airports. Ideally, that noise will disturb as few people as possible.